Okay, so today we're going to talk about operations and composition of functions. First, I think it's important to know the difference between these two things. So operations are those four basic operations you've been dealing with since you've learned math: plus, minus, add, subtract, multiply, and divide. So if you see one of those things, you're doing an operation. Versus a composition. Composition is when we put together more than one function. So put together more than one functions. Okay, so we're going to do operations to start with, and then we will do some compositions in the second part. So question A, 1A. So we're told that f of x is equal to 3x minus 2 and g of x is equal to x squared minus 5. So if you look at your questions A through D, that's going to practice all four. Plus, and then we're going to do minus, then we're going to do multiply, then we're going to do divide. So let's add these two functions first. Just as a way to write it, this is one option to write it. I really don't like this way of writing it. I would prefer to write f of x plus g of x. I think it's a little bit more clear as to what you're going to do. So this just says take your f of x function and add your g of x function. And since f of x is more than one thing, I'm going to use parentheses with every single one just to make sure I do everything correctly. So f of x is 3x minus 2 and I'm going to add, so plus g of x, which is x squared minus 5. So this is one particular case. Even though I wrote these things in parentheses, if you have a parenthesis with a plus sign in front of it, if you distribute plus, it really doesn't change. It really doesn't change anything. So even though it's a good idea to always write them in parentheses, sometimes it's unnecessary. So this is one of those cases where it really doesn't do anything. So I'm just going to rewrite it. If you distribute out a plus sign, again, it doesn't do anything. So 3x minus 2, you don't really have to even rewrite this, plus x squared minus 5. So when I write my final answer, I'm going to write it in descending order. So biggest exponents are going to be written first down to the smallest. And we should also combine those like terms. So I see the like term of negative 2 and negative 5. So my final answer will be written as x squared plus 3x minus 7. All right, let's do question B. So question B is, it looks very similar, but there's a minus sign in between. So it is going to be a very similar setup. I'm going to do f of x. Again, I'll just rewrite it so that I can see what I'm doing, minus g of x. So I'm going to take my f function and I will then subtract my g function from it. So rewrite your f function. So your f function, let me come back up here, is 3x minus 2 and I'm going to subtract my g function. So that's x squared minus 5. Now this time, putting parentheses around my f minus around my g is really important because I know that when there's a subtraction sign right here, that subtraction sign is going to have to distribute into the x squared and the minus 5. So I'll show that. So I've got 3x minus 2. I'm not changing that. but now I've got minus x squared, and that makes plus 5. Okay, so again, a final answer, we'll just go ahead and write in descending order, combining the numbers -2 and 5. So negative x squared plus 3x plus 3. And that's it for question B. All right, question C, f times g of x. When you don't see a operation between the two like this, when they're just right next to each other, it's kind of like if I told you 2a. Well, that just means take 2, multiply a. It's just understood that that's a multiplication. So same thing here. So this means we're going to take f of x and we're going to multiply g of x. So let's write f of x. Again, let's just be consistent with my colors and use red. So parentheses. If you ever wonder you should use parentheses, they never hurt. They sometimes are unnecessary, but it's better to be safe and write them in parentheses than not and miss a step. So I'm going to write these in parentheses. So think about this one. Does this cause anything to happen when you write them in parentheses like that? So it does. We have to do double distribution or foiling. So I have to do all of this now. So that makes 3x times x squared is 3x cubed. 3x times -5 is minus 5x. I'm sorry, 15x. -2 times x squared is minus 2x squared. And then -2 times -5 makes positive 10. Okay, so in this question, even though there's nothing to combine for like terms, I am going to write it one last time as a final answer going in the correct descending order. So 3x cubed minus 2x squared minus 15x plus 10. So that's our final answer in good form. All right, that last problem. So this is our division problem. And so rewritten is f of x over g of x. So I'm going to put my f of x on top. So that's 3x minus 2 over my g of x, which is x squared minus 5. Okay, and there's no simplification to do here. You can kind of assume there's not going to be any simplification unless it's really obvious on the division, because we actually haven't learned this, or at least that much about this. Now, if I go back up to the top really quickly, right here on my division, it says what we just did, f of x over g of x, and then it says comma g of x not equal to 0. So think about why that's there. G of x not equal to 0. What is that saying? So if you look at the location of that g of x, it's in the denominator. And so when it's in the denominator like that, all this is saying is, hey, don't forget that you can't divide by a 0. So it's mainly a reminder about domain. If I asked you what the domain was, you'd have to say, well, x squared minus 5 is not allowed to be 0 because it's in the denominator. So x squared cannot equal 5. X cannot equal plus or minus square root of 5. But I really am not going to ask you that. It's just kind of there as a mental reminder about domain. Okay, let's go on to composition. So this is where we're going to do some composition functions. So these are some alternate ways to write it. I don't really like using the open circle that much. I think it's a little bit less clear as to what we should do. So when I see the open circle like that, I go ahead and rewrite it how you see here, g of f of x. Okay? Or, so this is when the g is on the outside and f is on the inside. So this is what it looks like if f is on the outside and g is on the inside. Now it's really important which one's on the inside and which one's on the outside, because that's what tells you where to go or where to start. So that's really the only rule for compositions, is to start with the inside. And it's a really important rule though, because it's kind of like the just PEMDAS rule where you have to do parentheses first. The inside, by the inside, I mean what's inside the parentheses. So it's really just a rule about PEMDAS and following the correct order of operations. So let's go ahead and do question A. So we're told f of x is equal to x plus 4, and we're also told g of x is equal to square root of x. So question A wants us to do f of g of 3. So that rule says start with the inside. So the inside I've already boxed is g of 3. Okay, so what that tells me to do is to go to my g function, which is right here. Let me scoot over just a little bit. So go to my g function, and instead of using x, we're plugging in a 3 here. So square root, and we want to plug in 3 for the x. So square root 3. And none of us know what the square root of 3 is, at least not without a calculator. That doesn't simplify in any way. So that's as far as we can do for g of 3. So now we're going to go on to the outside. So this is g of 3. Now let's do the outside. Now the outside says use the f function. So f of, and instead of writing g of 3, I'm going to write what I know the answer to g of 3 is. And that's the square root of 3. It's what you just did. Okay, so now I go to the f function and I plug in square root of 3. So I go to the f function and plug in square root of 3. So instead of x here, I'm going to write square root of 3, and then I still have to plus 4. So remember it's x plus 4, so I'm going to use square root of 3 because that's my x, and then plus 4. So this is just writing what the function was. But square root of 3 and then plus 4. And again, this is not something you know how to simplify without a calculator. We have to leave it like that. If you can simplify, you will, but that's not something that simplifies into a real rational number. All right, so let's do question B. So I'm going to do it in that same way, where I'm going to do the inside in red first. So f of negative 2. So go to your f function, and you're going to plug in negative 2 for your x, and we want to add 4. So negative 2 plus 4. Alright, so when I plug in negative 2 and add 4, that simplifies down negative 2 plus 4 to 2. Alright, so now we got to do the outside. So it's basically like two things. You got to always do the inside first, and then after you get the inside, do the outside. So the outside is a g, and I'm going to plug in 2 here. So now I look at the g, and my g function is a square root of x. So where I see an x, I'm going to plug in a 2. So that's going to be square root of 2. And the square root of 2, if that's not a whole number that you know, or even just something that simplifies, then there's nothing we can do from that point, and that is going to be our answer for question B. So equals square root of 2. That is the composition of g of f of negative 2.
downstairs.
All right, so g of 9, this is the inside. We're going to do that one first. So we follow the g function. And when we follow the g function, we're going to plug it in right here. And it's equal to 3. All right, so then we're going to use the f function, and let me do this in blue like everything else I did. So now I'm doing the outside, and that's the f function, and I'm going to plug in a 3 here. So the f function tells me to use, so where's this? I'm going to do x plus 4. So I'm going to plug in the 3, and I'm going to add the 4. So 3 plus 4 is 7. Okay, and that's it. All right, so this is some more examples. So we're still doing the same thing on D. So f of negative 5 right here says, so do the inside first. So f of negative 5 is equal to, so we're going to plug in negative 5 for my x and then add 4. So I'm using this function. It tells me to plug in negative 5 and then add 4, and that's equal to negative 1. So now when we do the inside, or outside, the outside is a g. So I'm going to plug in g, and I'm going to use that number I just found here of negative 1. So now I'm going to my g function, and instead of x, I have negative 1. So square root negative 1. We haven't talked too much about this, so if you left it as this answer, that's fine. If you happen to recall that that's actually I for imaginary, that's fine too. I would have accepted either one of those answers. All right. Example E and F, these are our general composition functions. So the reason why I'm calling them the general composition function is because if you notice, it's not asking you to evaluate at a certain number. It's just F and then open circle G. So if you look back on the front page on page 1, under composition function, it actually shows you that this open circle right here is the same thing as that composition. I don't really like the open circle look, so I would take the time to rewrite F and then of G of X, because then it makes it much more clear which one is the inside. So that's G of X in this case. So we're still doing the same thing. It's just a little bit different because it's the general X term instead of a number. But the inside is G of X, and that's equal to, so I don't really know what it's equal to number-wise, but I do know that G of X is the square root of X. Okay, so then I do the outside. You can't simplify square root of X, so I'm going to leave it. So now I do the outside. And the outside, I'm going to use the letter F, or the function F, and instead of X, I'm using square root of X. So I'm just still following that same idea of plugging that into my F function. So I go to my F, which is here, and instead of X, I have square root of X. So instead of this X right here, I'm going to have square root of X. And then F told me to also add 4, so plus 4. Okay. All right. So if you want to pause this and try to do F, example F right here, before I start, I'm going to go ahead and start those. So F of X is equal to, so this time F of X, we know is X plus 4. So now I'm going to do G of, and I'm going to use X plus 4 here. So now I go to my G function. Instead of X, I have X plus 4. So X is under the radical. So underneath the radical, I'm going to put up X plus 4. So that whole thing is what the composition of G of F of X is. All right. example 3. I'm going to actually do example 3 in 2 ways, both of which are 100% good and correct ways to do it. It's just some people prefer one method and others another. So the first method is actually really similar to the front page that we did. This is the subtraction of the function f of x minus g of x. And then we're going to evaluate that subtraction function at 4. So my first step is to just do like we did on the front, take f of x and minus the g of x. So f of x is x squared minus 4. So remember, I like to put it in parentheses just so we make sure we do it all correctly. Minus g of x, which is x plus 3. So I know that that's really going to distribute that minus sign. So it makes negative x minus 3. And this thing's not changing at all. It's still x squared minus 4. So that makes x squared minus x minus 7. And now, so that's just the subtraction. We haven't actually done what the problem is asking us to do. The problem wanted us to evaluate at 4. So I know that again because of this 4 right here. It's saying evaluate at 4. So plug in 4 basically. So 4 squared minus 4 minus 7. So 4 squared is 16 minus 4 is 12 minus 7 is 5. So this method we got 5. I like this method because it's still doing the exact same steps that we did on the front. And then at the end, you just plug in your number. So you don't really have to remember something else. It's just we know that that means to plug in the number. Now, some people like to do the alternate method of saying, so f of, oops, I'm not going to use this color. Okay, so the alternate method is to say, well, f of x minus g of x evaluated at 4 is the same thing as f of 4 minus g of 4. I guess I should have used my colors at this point, so I'll start that now. So first I'll do f of 4 in red. So using the f function, we're going to plug in 4. So 4 squared minus 4, which is 16 minus 4, which is 12. And then g of 4, so g of 4 is 4 plus 3, which is 7. So 12 minus 7, we still get 5. So this one might be a little bit easier algebra-wise, but it's kind of like remembering a separate way to do a problem. It's really the same problem. It's just the evaluation using a number. All right, so if you want to do the now you tries, I'm going to do them really, really quick. So if you want to pause this, then you can try to do it and see if you get the same thing. So I'm going to go ahead and start. F of x is x squared minus 4. So now I'm going to do the outside, which is g. So that's going to equal, I'm plugging in x squared minus 4 here, and then I still have to add 3, which makes x squared minus 1. So that's the answer to the first one. Now if we do the second one, I'm going to go at that same speed. So g of x is x plus 3. So I'm using the x plus 3 here. I'm going to plug it in right here. Now I'm going to do f of x plus 3. So now I'm going to my f function. Instead of x, I'm plugging in x plus 3. This one's a little bit harder because notice that x has to get squared. So when I write x plus 3, I'm going to keep it in parentheses because I know I'm going to have to square that. So this is a little bit of algebra practice. We've been practicing this whole unit really. This means x plus 3 times x plus 3, which is, so if I show this, so that really makes x times x is x squared. X times 3 is plus 3x, plus 3x, plus 9. Okay, and don't forget, you still have minus 4. It's a really common mistake to just forget to write that because you focus so much on the foiling. But don't forget that minus 4. So total answer, combine 3x and 3x to 6x. 9 minus 4 is 5.